Aircraft carriers are powerful floating air bases, projecting air superiority, rapid response, and strategic dominance across oceans in modern naval warfare. USS Bataan is a WASP-class multi-purpose amphibious assault ship of the United States Navy, named in honor of the World War II Battle of Bataan in the Philippines. Commissioned in 1997 and homeported in Norfolk, Virginia, the ship serves as a vital element of the Navy Marine Corps team. Designed for transitioning forces from sea to land, Bataan is capable of supporting full-scale amphibious operations, humanitarian missions, and crisis response efforts. With a core crew of nearly 1,000 sailors and Marines, USS Bataan can embark a Marine Expeditionary Unit of around 2,000 troops, including the 1,200 Marines of the 22nd MEU during a recent deployment. The ship supports a mix of aircraft such as the MV-22B Osprey Tiltrotter, the AV-8B Harrier light attack jet, and various assault helicopters. Additionally, it can operate up to 3 landing craft air cushion, essential for ship-to-shore movement. USS Bataan was the first amphibious assault ship built with accommodations for female personnel, offering berthing for nearly 450 female officers, chiefs, and enlisted troops. In total, it can house up to 3,200 individuals, making it a highly capable and inclusive platform for modern naval operations. In 2011 to 2012, the USS Bataan completed one of the longest U.S. Navy deployments since the 1970s, operating across the 5th and 6th Fleet areas, with minimal notice departing just 2 weeks after orders and nearly 4 months ahead of schedule. Most recently, Bataan completed an 8.5-month deployment, participated in Fleet Week Miami and Fleet Week New York in 2024, and is now undergoing extended maintenance at the NASSCO shipyard in Norfolk. EOR. From AV-8B Harrier operations on its flight deck to the launch of MV-22B Ospreys and LCACs from its well deck, USS Bataan stands as a powerful, flexible force projection platform, ready to respond globally at a moment's notice. The Fujian Type 003 aircraft carrier marks a major leap in China's naval capabilities and technological confidence. Unlike its predecessors, the Fujian skipped the traditional outfitting process at the dry dock and was directly moored to the pier, suggesting a new level of industrial maturity and confidence in system integration. This bold move hints at China's significant progress in carrier design, shipbuilding precision, and modular construction techniques. Displacing over 80,000 tons, the Fujian is China's first fully domestically designed supercarrier. It features an electromagnetic Catapult launch system, similar to that of the U.S. Gerald R. Ford class, allowing it to launch heavier aircraft with greater efficiency and less wear. Its flat-deck design, without ski jumps, reflects a shift toward true catapult-assisted takeoff but arrested recovery operations, enabling it to host a more versatile air wing. Thou et ton. The rapid pace of its construction and fitting-out phase indicates an integrated and well-coordinated supply chain. Key modules, including radar, weapon systems, and island superstructure, appear to have been installed during hull assembly, greatly reducing outfitting time. The ship's early connection to shore power and testing facilities also supports faster system integration and sea trial readiness. The Fujian's development highlights China's strategic ambition to project power far beyond its shores. Its emergence sends a strong signal of China's determination to close the carrier capability gap with the U.S. Navy. The transition from dry dock launch to direct mooring not only showcases engineering confidence, but also reveals China's ambition to accelerate the timeline for combat readiness. In short, the Fujian is not just a shipment, it is a bold statement of China's technological and military rise. China's Type 003 aircraft carrier, Fujian, represents a major leap in the capabilities of the Dragon Navy, which now holds the world's second strongest conventional naval force. As the third carrier following the Liaoning 67,000 tons and Shandong 70,000 tons, the Fujian surpasses them with a displacement of over 85,000 tons. Uniquely, it features advanced electromagnetic catapult technology, making it one of only 2 carriers globally to do so. Entirely developed and built domestically, the Fujian marks China's transition toward carrier mass production. Backed by a powerful surface fleet including 8 Type 055 destroyers, 20 Type 052D destroyers, and over 100 frigates, the Fujian is the centerpiece of a growing, modern naval force. Prowler. An aircraft carrier is a powerful seaborne airbase at sea, enabling naval aviation to project air power globally without relying on land bases. It carries a full complement of fighters, AEW aircraft, helicopters, and drones, supporting roles like air defense, anti-surface warfare, anti-submarine patrols, and disaster relief. Carriers form the centerpiece of a carrier strike group, providing offensive strike capability, sea control, and strategic deterrence. Their mobility, flexibility, and sovereign presence make them indispensable for crisis response, global diplomacy, and command of the seas. The McDonnell Douglas F/A-18 Hornet is a twin-engine, supersonic, all-weather, carrier-capable multi-role combat aircraft designed for both air-to-air and air-to-ground missions. Developed from the Northrop YF-17, the Hornet was selected by the U.S. Navy in 1975 to meet the need for a versatile and cost-effective aircraft to replace older models like the A-4 Skyhawk and A-7 Corsair II. The FA-18 entered operational service in 1983 and was later adopted by the U.S. Marine Corps, as well as the air forces of several allied nations. The Hornet features advanced avionics, digital fly-by-wire controls, and multifunction displays, offering high agility and excellent performance in various combat roles including fleet air defense, close air support, suppression of enemy air defenses, and aerial reconnaissance. Its ability to carry a wide range of weapons further underscores its multi-role capability. The aircraft has participated in major conflicts such as the 1986 U.S. bombing of Libya, the 1991 Gulf War, and the 2003 Iraq War. It also served with the U.S. Navy's elite Blue Angels demonstration team. The Hornet formed the basis for the larger F/A-18EF Super Hornet, which gradually replaced both legacy Hornets and the F-14 Tomcat in naval service. Though retired from the U.S. Navy by 2019, the F/A-18 Hornet remains in use with the Marine Corps and other countries. It is celebrated for its reliability, maneuverability, and enduring value as a true multi-role platform in modern military aviation. Several F/A-18s line up on the USS Ronald Reagan's flight deck. Steam shoots from the catapult as each jet is launched at high speed, afterburners blazing, roaring into the sky in rapid succession. Despite China's rapid technological progress in recent years, developing high-thrust aircraft engines remains one of its most persistent challenges. The U.S. Air Force's F-119 engine, which powers the F-22 Raptor, exemplifies why American engines are still unmatched. Even if the F-119's blueprints were made public, reproducing it would be nearly impossible due to the extreme complexity of its mechanical structure, advanced materials, and ultra-precise machining. Aircraft engines must endure extreme temperatures and pressures. They require high-temperature resistant materials for components like turbine blades, while fitting a complete system turbines, fans, compressors, combustion chambers, afterburners, and cooling passages into a compact design that minimizes weight and size. This demands extraordinary engineering. The F-119 engine uses hollow single-crystal turbine blades with intricate internal cavities and freeform surfaces that can only be produced using cutting-edge machining. To date, only the U.S. possesses the technology to achieve this level of precision. Even with access to the design and material formulas, reverse engineering the engine remains nearly impossible. While China has made strides in structural design and invested heavily in engine development, it still lags 5 to 10 years behind in military engines and 20 years in large civil turbofans. In materials, science, and precision engineering, the core of aircraft engines, there are simply no shortcuts. On the USS George H.W. Bush, a Nimitz-class aircraft carrier, launching F/A-18 Hornets and EA-6B Prowlers is a complex and highly coordinated process. The cockpit, often called one of the most dangerous places to work in the world, buzzes with activity as the aircraft prepare for takeoff. The process begins with the aircraft being moved into launch position by tractor, guided by yellow-shirted operators. These operators use hand signals to precisely align each aircraft with one of the steam-powered catapults installed in the cockpit. Once aligned, the aircraft's nose landing gear is connected to the catapult shuttle with a launch rod, while final safety checks are performed by the green-shirted catapult crew. That's great. At the same time, the red-shirted weapons handlers will load the aircraft's weapons, and the purple-shirted personnel will refuel any jets as needed. Once the aircraft is locked into position, the jetpack will rise up behind the aircraft to protect the crew and equipment from the powerful exhaust. Inside the cockpit, the pilot performs a final pre-flight check, communicating with the carrier's control center. Once all systems are confirmed to be operational, the dispatcher will give a thumbs up and then kneel down to touch the flight deck, pointing forward to launch the aircraft. This initiates the launch sequence. In a matter of seconds, the steam catapults the aircraft from 0 to about 170 miles per hour, launching it off the flight deck and into the sky. This is a huge but crucial force, as it allows the aircraft to gain enough speed in a very short distance. The FA-18 Hornet, a twin-engine multi-role fighter, roars through the air with its afterburners burning, ready for a variety of missions, including air superiority, ground attack, or reconnaissance. Mais à l'Église. Soon after, the EA-6B Prowlers follow suit. These four-seat, twin-engine aircraft specialize in electronic warfare, jamming enemy radar, disrupting communications, and providing electronic protection for attack aircraft. Their unique shape and large underwing storage compartments make them easily distinguishable from the other jets on deck. The launch sequence is repeated for each aircraft, with incredible precision and timing. Between each launch, the deck crew quickly resets the catapult, inspects the deck, and clears any potential hazards to prepare for the next jet. Every move is practiced and synchronized, reflecting hours of training and discipline. Despite the physically demanding and hostile environment, the coordination between the pilots, deck crew, and controllers ensured each launch was executed flawlessly. This seamless operation demonstrated the full capabilities of naval aviation and its role in force projection. Despite the high noise levels, intense speed, and powerful jet exhaust, the launch process is executed with military precision. Every motion is rehearsed and disciplined. The teamwork between the carrier crew and aviators allows for rapid deployment of strike aircraft in support of missions over sea or land. The launch of the FA-18 Hornet and EA-6B Prowler from the aircraft carrier USS George H.W. Bush demonstrates the power, precision, and professionalism of carrier air operations, an impressive feat of engineering and human coordination at sea. Eachens. On October 13, 2020, USS Zumwalt successfully launched an SM-2 missile using the new Mk-57 vertical launching system at NAS Point Mugu. This marked the destroyer's first live fire test, showcasing its stealth, versatility, and role in advancing future naval combat capabilities. On May 14, 2013, the X-47B Unmanned Combat Air System demonstrator completed its first-ever catapult launch from the flight deck of the USS George H.W. Bush off the coast of Virginia. This marked a historic moment as the first time an unmanned jet was launched from a nuclear-powered aircraft carrier using a steam catapult. The launch process involved positioning the X-47B on the catapult track, connecting it to the shuttle, and performing final system checks. Once cleared, the launch officer initiated the catapult stroke, accelerating the aircraft rapidly along the deck and into the air. This successful launch demonstrated the feasibility of integrating unmanned systems into the demanding environment of a carrier flight deck. Vice Admiral David Buss described the event as a small but significant pixel in the future of naval aviation and a key step toward deploying autonomous aircraft in combat operations. On July 10, 2013, the U.S. Navy's X-47B made history by completing the first ever autonomous landing of an unmanned aircraft on an aircraft carrier. The bat-winged drone smoothly approached and landed on the USS George H.W. Bush, catching the arresting cable at 1:40 p.m. off the coast of Virginia. Prior to landing, it flew in formation with F/A-18s and was supported by a Seahawk helicopter. The X-47B operated on pre-programmed routes but had a human operator as backup. This milestone marked a major step forward in integrating drones into carrier operations. The process of unloading two AH-64 Apache helicopters from a C-17 Globemaster III is a carefully orchestrated operation involving both Air Force and Army personnel. It begins with the C-17 taxiing into position on a designated tarmac or airstrip. Once the aircraft is secured, the large rear cargo door is opened, and the ramp is extended to create a gradual slope for safe unloading. Ground crews position safety markers and ensure the area around the ramp is clear and level to support the weight of the helicopters. Inside the aircraft, the two Apache helicopters have been securely fastened using heavy-duty straps, chains, and locks to prevent movement during transport. Before unloading begins, soldiers and airmen work together to inspect the restraints and verify the structural condition of both helicopters. Any supporting braces, protective padding, or transport fixtures used to stabilize rotor components or sensors are identified and scheduled for removal. Once the final checks are completed, the crew starts by detaching the securing straps and unlocking the helicopter wheels. A specialized tow vehicle is attached to the first helicopter using a tow bar. Ground guides then take their positions alongside the aircraft, ready to provide precise instructions through hand signals and radios. The first Apache is slowly and carefully guided down the ramp, with all movements coordinated to maintain control and prevent damage. As the helicopter descends the ramp, the tow team monitors spacing and clearance on all sides. This step requires precision, as the rotor mast, landing gear, and tail must all clear the aircraft's interior without contact. Upon reaching the ground, the helicopter is towed to a designated reassembly and inspection area nearby. There, it is chocked and secured to await further setup. The unloading team then returns to the C-17 to repeat the process with the second Apache. The same detailed steps are followed, removing restraints, attaching the tow vehicle, guiding the helicopter out, and moving it to the designated area. After both helicopters are unloaded, crews begin the reconfiguration process. During air transport, components such as rotor blades may be detached or folded to fit within the C-17's cargo bay. These components are now carefully unfolded and reinstalled. Technicians conduct a series of system checks including hydraulics, avionics, fuel systems, and engine integrity. This ensures the helicopters are fully mission-ready. Once reassembly is complete, the helicopters are either test run on-site or prepared for immediate deployment. They are then moved to their assigned mission area or flight line. Throughout the entire process, every action is performed with an emphasis on safety, coordination, and efficiency. The successful unloading and preparation of Apache helicopters highlights the seamless collaboration between branches and the logistical capabilities of the U.S. military. A 12.7mm machine gun live-fire exercise was conducted at sea aboard the USS Monsoon destroyer in the Pacific. The target used was an old abandoned lifeboat. This training allowed the crew to practice aiming, firing accuracy, and response under real sea conditions, enhancing their combat readiness in maritime operations. On the flight deck of the USS Theodore Roosevelt, Super Hornet fighter jets prepare for catapult-assisted takeoff. First, the aircraft is taxied into position by flight deck crew and aligned precisely with the catapult track. Ground personnel then hook the aircraft's launch bar to the catapult shuttle. Once locked in, the jet's wings are unfolded, and final checks are performed by the yellow shirts and other crew members. The pilot powers up the engines to full throttle while holding the brakes, building up thrust. When everything is cleared, the shooter signals launch. Instantly, the catapult fires, propelling the Super Hornet from 0 to nearly 170 miles per hour in under 3 seconds. The nose lifts, and the aircraft takes off into the sky. Meanwhile, deck crews brace against the blast and prepare the next jet. This rapid cycle of high-intensity launches showcases the precision, power, and coordination required for modern naval aviation operations on a moving carrier at sea. Fighter aircraft are highly maneuverable military planes designed primarily for air-to-air combat against other aircraft. Their main role is to establish air superiority by intercepting and destroying enemy fighters, bombers, or drones. Unlike bombers or transport planes, fighter jets emphasize speed, agility, and advanced weapon systems. Modern fighters are equipped with powerful jet engines that enable them to reach supersonic speeds, sophisticated radar and targeting systems for long-range engagement, and an array of weapons such as air-to-air missiles, cannons, and electronic warfare tools. These aircraft often incorporate stealth technology to reduce radar detection and enhance survivability in hostile environments. Fighter jets are generally categorized into generations. For example, fourth-generation fighters like the F-15 Eagle or Su-27 offer advanced avionics and multi-role capability, while fifth-generation fighters such as the F-22 Raptor or Su-57 add stealth, supercruise, and sensor fusion. Nations continually develop new fighters to maintain technological superiority in aerial warfare. Fighter aircraft can be launched from land bases or aircraft carriers, making them vital assets in both defensive and offensive operations. Their presence not only deters threats, but also ensures control of the skies in any military campaign. From dogfights in World War II to high-tech missions today, fighter aircraft remain essential tools in modern Air Force.